Recording's going. And Arjun, are you ready to get started? Can I see a thumbs up?
Yeah.
Great, fantastic. Okay. Welcome to room two, everyone. We're gonna have a lot of fun here today. First, we are going to be hearing from Arjun Kochar, who was mentored by Moritz Baumgarten, and he's going to be presenting his work, band gap predictions for hybrid organic inorganic perovskites using machine learning. Arjun, take it away.
Right. Thank you. The amount of solar energy that hits the Earth in 1 hour can power for an entire year. So why aren't we able to harness all this energy? Hello, everyone. My name is Arjun Kochar, and welcome to my presentation, Band Gap Predictions for Hybrid Organic Inorganic Perovskites using machine learning. Today, around 95% of the world's solar energy comes from silicon solar cells. However, there's a relatively new material class that is able to beat their efficiency at a much lower cost. Perovskites. Alongside affordability, perovskite solar cells are flexible and are therefore predicted to be able to double as windows or be placed on the roof of a car. Arguably, the most important plus point of these materials is the band gap. The band gap of a material is the energy difference between the valence and the conduction band. When a photon hits an electron, it excites it into the conduction band, and from there the electron travels from one electrode to the other, creating electricity, and then it recombines with its hole. Because each photon does not have the same amount of energy, the band gap dictates energy losses too. If the sun always emitted high frequency light, a larger band gap would capture more energy and vice versa. Based on the frequency of light the sun most often emits, the optimal band gap is between 1 and 2 eV. So if this material is affordable, efficient, and flexible, why is it not being used? The problem with them is that they last 1/5 the amount of time a silicon solar cell lasts. Scientists are now trying to find new stable perovskites with similar advantages, and this model will help them do that. Because of the band gap's importance in minimizing energy losses, it can make or break the photovoltaic potential of a hybrid perovskite. Therefore, we are presenting a model that can take hybrid perovskite crystals as an input and output its band gap. We have used convolutional neural networks for the model. The first step is to create a computational representation of the crystal. This representation contains information like atom type, interactions between atoms, and the bond types. Each time a crystal goes through a convolutional layer, more is learned about each atom. All this information is stored to be used by the pooling layers to combine each atom's features into a crystal. The number of convolutional layers is very important because it decides which features of a crystal are ignored and which are used when predicting the band gap. The hidden layers are what captures the patterns between different crystals. Now, let's look at the results. The model was trained, validated, and tested on a data set of 1,346 crystals. It obtained a mean absolute error of 0.075 electrovolts on the training set and 0.156 electrovolts on the testing set. The histogram bar chart shows that 77% of our predictions have an error less than or equal to 0.2 EV, and 62% have an error less than or equal to 0.15 EV. These values demonstrate negligible error. While training, we also wanted to balance the training time with model accuracy to make the model accessible to all researchers. The pre-trained model, which we've made available to the public, takes less than 10 seconds to run on a consumer laptop. In the end, perovskites are one of the most prominent fields of study for progress in solar cells and green energy. Our research presents a model that predicts band gaps with accuracy comparable to calculations that take hours longer. We hope this model is used to sort hybrid perovskites into two buckets. Ones that have photovoltaic potential because of their band gap, and ones that don't. We hope this model makes finding the next solution easier. Thank you, Moritz, for all your mentorship. Thank you, SRI staff, for organizing this program. Thank you all for listening to my presentation. Thank you.
Great job, Arjun. Thank you so much. All right. That was a textbook fantastic presentation, and exactly what we want to be going for as we're through this process. So with that, considering we're behind, we will go to the, that's not the next one. We will go to the next. Arian, are you here, ready to present?
Yep.
Fantastic. Okay. It is 9:29. We will go until 9:35. You may start whenever. Oh, nope, you may not. Sorry, I need to introduce you. Okay, here we have Arian Sharma, mentored by Joyce Kwan. Arian will be presenting his work, Broccoli, a neural network-driven enhancement for improved impact factor characterization in life cycle impact assessments of solar energy datasets. You have 5 minutes until 9:35. Your time starts now.
All right. Hello, everyone. My name is Arian Sharma, and this is my project. So essentially what I was trying to do was I was trying to improve the accuracy and efficiency of life cycle impact assessments of solar energy using neural networks. So as a little bit of a background, right now, human impacts on the environment are increasing in severity. And as people start looking at the world from a sustainable lens of development, many tools have been developed to aid this process. One of these tools is the LCA, or the life cycle assessment, which is a computer-based data-driven model to assess the environmental footprint of a material, service, product, just about anything. So yeah, that's kind of what the life cycle assessment is. And there are 4 steps to it. The first 2 steps are kind of based in defining the environmental impact factors, or EIFs. EIFs are kind of the inputs or the outputs of the product. So whatever the product is taking in to consume and whatever it's putting out at the end of its life cycle. So the third and the 4th steps are more based in actually interpreting and creating data. So that's where the life cycle impact assessment comes in. The life cycle impact assessment, or LCIA, is an algorithm that's assessing the environmental impact of a product based off of how many environmental impact factors it has. So these could include things like truck fuel consumption, hydrogen, oxygen, There are thousands of these data sets available that are published and created by researchers, businesses, governments alike. So moving on, machine learning is kind of, obviously, it's when computers are learning algorithms and learning data by themselves. And I specifically use neural networks because my model requires supervised learning due to its use of classification and regression. Number one, classifying environmental impact factors into different impact categories. And number two, using the impact categories to create environmental footprint metrics, which is the regression part. So kind of, so first we have to ask, like, why am I doing this? So right now, LCAs are being used very often by researchers, businesses, and governments, as I mentioned before. But there are several issues. For one, LCAs are usually conducted on the open LCA software. And an issue with that is that it only can take in data sets of its trademark file type Zulka. This is compared with most researchers publishing their data in CSV files or spreadsheets to share with each other. So this means that a lot of the data that's being published is not always very accessible. So there's an issue with accessibility. The second issue is with the accuracy. So LCAs kind of take most of their data in. So LCAs kind of usually, their data comes in from, where was I? Oh yeah, so LCAs usually take their data in and they kind of use the environmental impact factors solely in order to address the environmental footprint of a product. So this would mean that when given two different like paper towel brands, for example, an LCA would assume that they have the exact same environmental footprint and just make that approximation. That could be useful in the past, but now the products are being developed more sustainably. Then the need to have more accurate environmental results is very important. So right now, lots of machine learning methods have been used. Neural networks have been used in LCAs for things like extrapolating data, for using semantic searches to have better environmental impact factor matching, and many others, but none of them have been really used for what I'm trying to do here. So moving on, I created the feed-forward neural network in order to properly enhance an LC in order to enhance the LCIA. So the program was kind of in three sections. First one, having many core functions. So the function to build the neural network and that kind of data, the function to take out JSON files. So adding onto that, we created a file upload software that essentially consisted of many different file upload software. So instead of requiring the Zulka file, it would take zip files that can be taken from anything, spreadsheets, CSVs, and it would take out data from those files using a for loop. So, and then that was kind of the second part of the code, and the final part was the actual main training and evaluation of the neural network, and that's where we kind of can get into the in silico results. So, in general, the product was able to completely compile all of the thousands of JSON files into one data frame and publish that out. So, and you can see that at the top of the results over there. So it correctly characterized all of the EIF factors into their correct impact categories. So it was able to do that. In terms of the loss and MAE metrics, they were generally decreasing over time, as you can see in the graph. And the training and the validation loss was, and MAE was generally much less than the training loss, which indicates that the model was learning over the different epochs. In conclusion, this creates a very general and adaptable product that can be used for many types of solar energy, and it can be used for renewable energy as a whole if trained on different data. And this creates higher accuracy, higher accessibility, and more importantly, more usability for LCIAs. I'd like to thank my mentor and all of you guys for listening. Thank you.
Good job. Okay, that was fantastic. Yes, claps, definitely. Now we will be moving to our next presentation, which will be from Arian Shashi Kumar, mentored by Jae-Yoon Ju, titled Bioinformatic Analysis of Metabolism Pathways in Glioblastoma Multiforme. Your time, Arian, will start in a minute at 9:36, and we'll go until 9:41. Just want to confirm you're here, Arian? Yes, yeah. I see you there. Awesome. Are you ready?
Yeah, I'm ready.
Okay.
All right.
36, let's go.
All right, so good morning, everyone. My name is Arian Shashi Kumar, and today I'll present my research on the bioinformatic analysis of metabolism pathways in glioblastoma multiforme, or GBM. And this study was conducted by me, Arian Shashi Kumar from Marvin Ridge High School, and my mentor, Jae-Yoon Ju from Yale University. So glioblastoma multiforme is the most aggressive and invasive form of primary brain tumor
The prognosis for GBM still remains poor, with the median survival time from diagnosis approximately 15 months and a 5-year survival rate, which is less than 5%. Even with aggressive treatment, almost 85% of patients do not survive beyond 5 years. And this highlights some urgent need for new therapeutic strategies. So why study metabolism pathways? So understanding metabolism in GBM is vital because it can uncover the tumor's metabolic vulnerabilities and shed light on its aggressive behavior and treatment resistance. And it can help identify biomarkers for diagnosis and prognosis. So metabolic reprogramming is where cancer cells alter their metabolism to support rapid growth and survival, which is a hallmark of cancer. So by studying these pathways, we can identify new therapeutic targets and develop strategies to inhibit tumor growth, ultimately aiding in the development of personalized therapies for GBM patients. So in this study, we profiled the metabolic status of 156 GBM patient samples using gene expression data from the Cancer Genome Atlas, or TCGA. So normalized gene expression values on all 20,501 genes were used for this analysis. So metabolism pathways and their associated genes were retrieved from the KEGG database using the KEGRES package. A total of 12 major metabolism pathways were investigated, consisting of 87 specific metabolic pathways and 1,701 unique genes. So all of the analysis reported in the study was performed using the R program. So the GSVA package was used to calculate the gene signature scores for metabolism pathways corresponding to 87 specific pathways. So the gene set variation analysis, or GSVA, represents an unsupervised and non-parametric approach to gene set enrichment analysis. So the expression data were mean-centered and scaled before performing the statistical analysis, and the association of metabolic pathways to GBM subtypes, MGMT status, and gender was evaluated using non-parametric tests, with the significance threshold set at a Benjamin-Hodgberg adjusted p-value of less than 0.05 and a nominal significance at p less than 0.05. So our analysis revealed that the significant associations between GBM subtypes and various metabolic pathways, specifically the mesenchymal subtype, exhibited upregulation in almost all the metabolic pathways, whereas the proneural subtype showed downregulation in Figure 1. So key pathways affected included the carbohydrate, lipid, and amino acid metabolism. In Figure 2, the majority of metabolic pathways were dysregulated among different GBM subtypes. The mesenchymal subtype had upregulation in almost all the pathways, whereas the proneural subtype had downregulation in all the pathways. So, for instance, the mesenchymal subtype had significantly higher drug metabolism signatures, whereas the proneural subtype had significantly lower drug metabolism signatures. And in general, there is no significant correlation between MGMT status and the metabolism, except in ascorbate, aldehyde metabolism, and D-amino acid metabolism pathways. Although there was no significant correlation between gender and metabolism, a weak association was found in nitrogen metabolism. Nitrogen metabolism, pathogenate, CoA biosynthesis, and vitamin B6 metabolism. So there was a strong difference in survival outcomes between different GBM subtypes, with patients having the proneural subtype live longer on average. So this highlights the complexity of GBM, and it suggests that targeting metabolic pathways alone may not be sufficient for improving survival, but it could be part of a multifaceted therapeutic approach. So in conclusion, our study demonstrates that targeting metabolic pathways offers promising therapeutic opportunities to disrupt GBM growth and survival. However, challenges such as metabolic plasticity and the need for extensive validation remain. The metabolic landscape of GBM is complex, and further research is essential to fully understand the metabolic vulnerabilities of GBM. Future studies should focus on validating these findings in preclinical models and exploring combination therapies that target multiple metabolic pathways, and additionally investigating the role of the tumor microenvironment in metabolic programming could provide further insights into GBM biology. Thank you for your attention.
Fantastic. Great job, Arian. Thank you so much. All right. Next, we will be hearing from Augustus FAL, mentored by Simran Bawa, who conducted work exploring AST, ALT, and related hematological levels as biomarkers for diabetic retinopathy and diabetic macular edema. We will start the presentation at 9:42, and it will go until 9:47. Augustus, feel free to start whenever.
Okay, so type 2 diabetes affects approximately 500 million people around the world, with ocular complications being in the forms of diabetic retinopathy and diabetic macular edema, DR and DME, in short for diabetic retinopathy and diabetic macular edema, respectively. They are leading causes of blindness worldwide, and the prevalency rate of the Southern Chinese patients that we used was approximately 25%. Now, only very few patients with DME and especially DR have early symptoms. So with a leading cause of blindness around the world, we aimed to find, to explore the first association as a biomarker of liver enzymes with DR and DME to catch it. With the NIH approximating that vision loss could be caught by 95% with these diseases. So hi, I'm Augustus FAL, and my research explored AST and related hematological levels as biomarkers for diabetic retinopathy and diabetic macular edema. So what does this mean? DR is whenever blood vessels in the retina become damaged and they start to leak into the eye. DME is whenever the retina and the blood vessels around it leak into the center part of the retina, called the macula. Now, this study came from the idea of a paper that we found, which showed non-alcoholic fatty liver disease, which basically means if you have a damaged liver, which is found to be in association with type 2 diabetes. Now, the idea came from NAFLD, for short, having an inverse association with diabetic retinopathy. Now, no studies have, we could not find any studies studying between AST and ALT, or that was the closest study that we could find related to it. So as you can see in the results, we found that lower enzyme levels, ALT and AST, which is what we're primarily studying, were found to have a very significant p-value under 0.001 with DR and DME. Now, why is this important? Many patients with DM and DME have no early symptoms. The goal of this paper overall was for healthcare providers to take these findings into account when interpreting test results. Additionally, this research can be used as a stepping stone for a novel biomarker. And finally, it affirms previous research with NAFLD. So the methods that we used for this were RStudio and the Zero et al. Protocol. We used the Zero et al. Protocol to examine if there were abnormalities with the data distributions and to hopefully transform all the data into normal distributions. We used the two sample t-test to find the association between each of the characteristics that you can find on the table with DR and DME. And then finally, I used the Fisher's exact test to find the correlation between the sex. So as you can see, the goal of the main idea of this is that it can be used as a stepping stone for a novel biomarker to hopefully cut vision loss by approximately 95%. So thank you everybody for listening. Thank you. Everybody before me had such great talks. Thank you to my amazing mentor, Simran Bawa. So thank you guys, and I'm gonna hand it over.
Fantastic, great job, Augustus. Okay, we are making back time, everyone, which is great, but also no pressure to rush through your presentations. We're totally fine. So next we will move it right along. We will be hearing from Aya Sharawar, mentored by Suho Shin, affirmative actions and superscoring policy. We will go from whenever Aya starts until 9:51. Aya, whenever you're ready.
Yes, I'm ready. Hello, good morning to all. My name is Aya Sharawar from High School Buskara, and today I will present my research about affirmative actions in superscoring policy. Admissions into university usually favors students coming from a well-off financial background. Rich students can take a test several times with the aim to improve their score considerably, and gain entry into university. This is therefore to disadvantage students from poor backgrounds who can afford only a single test. This not only disadvantages students themselves, but also works to perpetuate disparities within society, which undermines overall social mobility and thus access to equal opportunities. We put students into a high or low ability groups. High ability students are those obtaining higher marks in exams, whereas low ability students score lower. At the same time, a student is considered two bases: financial status, being either rich or poor. Rich students take the exam multiple times and report their highest score achieved, whereas poor students take it only once. Keeping in mind these two disparities, we consider two types of affirmative actions. First of all, bonus points, adding a fixed points to the scores of poor students so that the chances of admission become fairly equal to everyone. Secondly, reserved seats. It ensures that a certain number of students is explicitly provided for poor students to ensure their proportionate representation. Yeah, our simulations showed that both affirmative actions improve acceptance rates and shifting acceptance probabilities to closer to rich students and ensuring fair admission for students with financial handicaps. We used a stylized model to analyze the impact of affirmative actions on admission through simulations with various score distributions. Graph X, as you can see, Graph X displays acceptance probabilities and confidence intervals. Graph Y showed that adding bonus points helped level the playing field. And Graph Z demonstrates that acceptance probabilities change with increasing reserved seats. One of the most interesting insights to be taken from our research is that extremely small chances in bonus points or number of reserved seats can matter for fairness, as illustrated by the potential to double chances of poor students being accepted. This highlights the need for further exploration into their impacts on student behavior and theorize different actions amounts. Yeah, I attach great importance to this study as I saw so many gifted young men of potential waste their careers just for financial disparities. These experiences installed in me the value of education accessibility and equity for everyone. Lastly, I would like to thank and gratitude my mentor Suho Shin and the Harvard Open Bio Undergraduate Laboratory Student Research Institute. Thank you for listening.
Wonderful job, Aya. Thank you very much. Next, we will be hearing from Ayat Nayar, mentored by Carlos Rivera. The project title, The Biochemical Symphony of RNA Polymerase III and its Dissonant Collapse in Autoimmunity. Ayat, whenever you're ready to begin, you may go until 9:55.
All right, so I'll begin right now. So hello, I'm I, and our project explores RNA polymerase III, abbreviated POL3, and its role in human systemic autoimmunity, where the immune system attacks multiple organs across the human body, and where POL3 seems to be dysregulated apart from the normal harmony observed. POL3's functions are less understood compared to other RNA polymerases, so we aim to clarify its non-canonical biochemical, epigenetic, and metabolic roles in blueprinting autoimmune disease, and will thus propose novel therapeutic strategies based on our literature synthesis. But let us first put this into a historical perspective. What are RNA polymerases and when were they discovered? Well, RNA polymerases are enzymes that synthesize RNA from DNA templates, and they were discovered in the 1960s by Robert Reuter, who identified the three distinct classes. Of the three RNA polymerases, POL3 is the largest and perhaps the most complex, being in charge of multiple RNAs that are critical for survival, such as transfer RNAs and 5S ribosomal RNAs, and others critical for stress responses, such as short interspersed nuclear elements, which are also short strands of RNA. Moving on to POL3 in biochemistry. POL3 is a 17-subunit hollow enzyme, which includes a 10-subunit core and additional subunits for regulation and stability, where its structural composition is detailed in Figure 1. The cytoplasmic pool of POL3 is involved in immune responses and antiviral defense. POL3 promoter recognition varies depending on gene type and types of RNA being coded, with specific transcription factors aiding in the process and binding to POL3, such as transcription factor 3A, 3B, 3C, etc., as as detailed in Figure 2. Pol3 is also sensitive to polyuridine tracks or bases of uracils and thus terminates transcription, as also detailed in Figure 2. Now let's move on to Pol3 regulation. Pol3 is regulated by metabolic inhibitor MAF1, which is sensitive to nutrients and stress. It inhibits Pol3 via pathways involving the mechanistic target of rapamycin, mTOR, AMP-activated protein kinase, AMPK, and protein phosphatase 2A or PP2A, as shown in Figure 3, where AMPK phosphorylates mTOR, which dephosphorylates MAF1, mediated by PP2A, and leads to MAF1's nuclear translocation and inhibition of Pol3 activity. Stress conditions like starvation and viral infection affect Pol3 activity, and autophagy, which is basically cellular recycling, plays a role in managing cellular resources, with regulation being context dependent. So the cell will cater to its needs efficiently to conserve resources under stress. Pol3 transcripts are also increased under stress, especially signs like ALU and B elements. Now let's connect this with epigenetic regulation. Pol3 transcription is influenced by chromatin modifications. Open regions of euchromatin facilitate transcription, while dense compact regions of heterochromatin inhibits it. Histone acetylation and phosphorylation promote Pol3 transcription, whereas methylation can either activate or repress it. Factors like the TF3C subunits exhibit histone acetyltransferase or HAT activity, and likewise chromatin remodelers can interact with Pol3 to influence transcription and create open chromatin environments by interacting with these specific modifications in HAT proteins, as shown in Figure 4. However, it remains to be clarified whether Pol3 can recognize specific epigenetic marks and bind to them, however. But what is the big idea of everything I've said so far? Well, by understanding Pol3's epigenetic and metabolic regulation as adaptive responses under stress, we can apply the same knowledge to garner a better understanding of its role in autoimmunity. And as such, Pol3 is crucial for immune response, detecting viral DNA and triggering inflammation. It converts this viral DNA into RNA, which activates immune pathways, as shown in Figure 5, producing inflammatory molecules such as cytokines and type 1 interferons. Dysregulation of these processes can lead to autoimmune diseases like lupus, systemic sclerosis, and Sjögren's syndrome, where patients express antibodies against Pol3 and its associated transcripts, including LA and Rho60 to be specific. Stress-induced granules, the genetic elements, might also contribute to autoimmunity if they escape and are misidentified by the immune system. We invite the audience to delve into more detail regarding these intricate mechanisms through our literature review. But let us put this in a genetic context. Autoimmune diseases disproportionately affect women, potentially due to faulty X chromosome inactivation or XEI, where one of the X chromosomes is randomly turned off, causing the wrong genes to be expressed, which can increase ALU and Pol3 transcript levels and contribute to autoimmune responses. And now, putting everything we have said together, many questions remain unanswered in the field, and thus further research should explore Pol3's response to various stressors, the non-uniformity of transcriptional patterns, and the role of Pol3 in XEI. Proposed therapies should target Pol3 cofactors and protein interactors through gene editing, Pol3 and epigenetic inhibitors, or T-cell therapies targeting autoantigens. And then, thus, clinical trials are warranted, and while progress in understanding Pol3's role in autoimmunity is significant, further research is necessary. Our review attempts to synthesize these current findings and proposes avenues for further research and therapeutic development. Pol3's role spans multiple disciplines, and it offers unique contributions to many fields. I'd like to thank the audience for listening to my presentation, as well as the Harvard Open Bio team. Thank you.
Thank you very much, Shia. Fantastic job. Okay. Next, we'll be hearing from Jang, mentored by Kumar, and project title Non-Hemostatic and Underrepresented Hemostatic Genetic Risk Factors in Deep Vein Thrombosis. Your presentation time will go until 10:01. Feel free to begin when you're ready.
10 million people. That's the amount who get deep vein thrombosis, or DVT, every single year. DVT is when a blood clot forms in a deep vein, which can loosen and lodge somewhere in the body. That can be highly dangerous and unpredictable. You could explode. Just kidding, you won't. But there are pretty bad effects, like choking to death on a blood clot. My parents always used to say, exercise and don't laze around all day, or else you'll get DVT. True, but in reality, DVT has a genetic origin that influences the majority of cases. But what kinds of genetic factors are lurking in the dark behind DVT? To introduce myself, my name is Azzy, and today I will be telling you about my literature review of non-hemostatic, underrepresented hemostatic genetic risk factors in DVT. You guys can zoom in and follow along on the poster as I talk, since it has definitions and stuff that you definitely can't miss. These lesser-known genes have a huge impact on DVT. This review is meant to be the first ever easy-to-understand standardized guide for future research about them. So you guys can now take a breath of relief too, because I will not be showering you with complicated jargon today. So, what did I do? As you can see in Figure 1 under Methods, I followed the PRISMA guidelines and searched 5 databases, getting 291 studies. I manually reviewed the title and abstract of all 291, but I had to remove 225 that met exclusion criteria. You can see tables of criteria that I used to choose studies to the bottom right of the Methods box. This left me with 51, and I read the full text of all 51 to collect the results. After that, I sorted them into subgroup analyses. But then I discovered there is also a huge extent of statistical diversity in these studies because of all the different statistical models, such as Mendelian randomized studies. That gives my review a great amount of varied, robust results. But then you may want to know, what are the results themselves? We found that 90 genetic risk factors total cause DVT. You can see a breakdown under the results and discussion section. And if you see this giant figure 2 on the bottom right of my poster, that's basically the culmination of my work. This is a 4-way Venn diagram presenting every single genetic risk factor compiled from this review and their origins I have determined. But that's not everything. We also found that many genes follow chain reaction models. Take a look at Figure 3 to the left of Figure 2. The top 2 boxes here show that genes can cause a change in something else first, that then leads to increased risk of DVT. Really sneaky, huh? But that's not all of their tricks. The bottom rectangle shows that some genes are only activated with certain triggers. For example, there is only an increased risk of DVT with the KEAP1 gene if you are both Chinese and underwent orthopedic surgery. Let's say you are both Chinese and did surgery, and you found out yesterday you have KEAP1. Oh no, it's the end of the world, right? Thankfully, it's not. Some ethnic backgrounds and such are strongly correlated with certain DVT-causing genes, but these people concerned can avoid acquired risk factors to minimize risk. So exercise at least 30 minutes a day, don't smoke, and you should probably be fine. People should also be assessed on a case-by-case basis, so more targeted preventative measures can be developed. To conclude, it is really important to emphasize that this review is the first ever to summarize and synthesize all current findings related to these genes' influence on DVT. Nobody else looked at them as a whole, even though they're really important. Because it's both a novel and holistic approach, this review can be used for future measures to prevent people from getting DVT and develop more targeted treatment to prevent more suffering in the millions of people affected, especially in prevalent minority populations that aren't studied consistently until now. But I couldn't have done everything here by myself. So last but not least, I'd love to thank Harvard Open Bio and my mentor, Fadwa Kamari, for supporting me and making this review possible. I'd also like to thank you for listening, and I hope that you learned something new. Remember to exercise, don't smoke, and maybe, just maybe, get a genetic screening. Thank you.
Thank you very much, Azzy. Great job. Okay. Now we will be hearing from Bianca Adan, mentored by Christian Covington, and their work identifying biomarkers for early detection of ovarian cancer using SHAP analysis. Bianca, feel free to take it whenever you're ready.
Hi everyone, my name is Bianca. My project focused on advancing the early detection of ovarian cancer using machine learning as well as a SHAP analysis to identify significant biomarkers. We focus on ovarian cancer because it's one of the leading causes of cancer deaths among women, as well as it tends to be asymptomatic at its earliest stages. Because of this, more than 70% of women are diagnosed with the disease in a late stage, which drastically reduces the 5-year survival rate. Current diagnostic methods for ovarian cancer are both invasive and sometimes inaccurate, with the advanced imaging technology being in place, having a high frequency of false positives. Serum biomarkers hold potential as a non-invasive diagnostic method that can improve the early detection of ovarian cancer, with several already showing promise, such as HE4 and CA125. However, many are not specific or sensitive enough to be used in a clinical setting, with these measures showing us not only how well these biomarkers can diagnose the disease, but also minimize the rate of false positives and negatives. Additionally, traditional biomarker approaches are both costly and resource intensive. We aim to mitigate these problems by using machine learning, which provides an efficient way to analyze data, and a SHAP analysis, which assigns each input feature, in this case our biomarkers, a value representing its impact on model output. We use 4 different machine learning approaches to gain a comprehensive understanding of our data, and as seen in our flowchart, we used a publicly available dataset containing information from 349 ovarian cancer and benign tumor patients. The dataset included 49 variables that served as predictors of ovarian cancer presence. We assessed the performance of all of our models using 6 different evaluation metrics that displayed how well each model was able to distinguish between the benign and ovarian tumor cases. All of our models had high quality performance in comparison to our baseline, which was the majority class classifier. To identify the top 5 diagnostic biomarkers, we analyzed the SHAP plots seen in Figure 3 for the 4 models and looked at the ranking at which they appeared as well as the consistency of these biomarkers. We identified HE4, CA125, NEU, ALB as significant biomarkers. From the plots, we were also able to understand how the values of the biomarkers can impact classification outcome. For example, patients with higher values of HE4 and age had a higher chance of the model predicting that they had ovarian cancer. Our findings of HE4 and CA125 were consistent with previous studies. However, these biomarkers tend to be expensive and not accessible in some cases. However, our findings of NEU and ALB show promise, as these are more accessible options and low cost. We aim to not only identify biomarkers, but also find a highly sensitive and specific solution that can possibly be implemented in a clinical setting. We calculated the sensitivity and specificity for individual biomarkers as well as in combination. The pairing of CEA and HE4 provided the highest sensitivity and specificity, as well as the combination of HE4, CA125, NEU, and ALB. This study shows that combining biomarkers in most instances provided higher metrics. However, the exact combination of biomarkers that should be used should be clinically validated and confirmed for the diagnostic capabilities. Our study showed that machine learning technology is an efficient tool to identify biomarkers, and further studies should focus on examining our results and possibly creating a comprehensive biomarker panel after clinically validating our results. That is both low cost and accessible. Thank you guys for listening, and thank you to my mentor for helping me.
Well done. Thank you very much. Okay, I have great news for everyone. We are actually back on time, which is really exciting. So now the schedule that was provided to you and sent in the chat earlier is the schedule we will be following. So our next presentation from Bianca Kapali, mentored by Jinwoo Kim, estimating the result of depression through instrumental variables, a comparative study of Canada and the United States. We'll begin at 1:06, so a minute from now, and go until 1:11. Bhavya, you are welcome to start whenever ready.
Thank you. Hello, everyone. My name is Bianca Kapali. I'm a rising sophomore at Juanita High School in the Cambridge program. And today I'll be presenting a study titled Estimating the Result of Depression Through Instrumental Variables, a comparative study of Canada and the United States, conducted in collaboration with Jinwoo Kim at Cornell University. Our study aims to estimate the causal impact of depression treatments on suicidal ideation among adolescents. Given the significant rise in depression and its association with suicidal ideation, previous studies often failed to control for confounding variables leading to biased outcomes. Randomized experiments are limited by ethical considerations, making it difficult to be conducted. We use instrumental variable estimation with Canada and the United States as instrumental variables due to their differing healthcare systems. Also, we control for potential confounding variables between nation and the outcome, such as illicit drug use. In terms of Figure 1, this graph shows the relationship between instrumental variable, in our case, the country, treatment type, and suicidal ideation, demonstrating how our IV method rules out problems from confounders. Our data comes from, first of all, Canada's Mental Health and Access to Care Survey, second of all, the U.S. National Survey on Drug Use and Health, both from 2022. These datasets provide comprehensive information on depression, treatment types, and demographics of individuals. This bar graph displays the distribution of variables like treatment types and illicit drug use in the Canadian and US datasets. We use the IV method to rule out confounded paths by treating the country as an instrumental variable. Our findings show that counseling's effect on suicidal ideation varies. Without controlling for illicit drug use, results were inconclusive. Among those who used illicit drugs, counseling slightly increased suicidal thoughts. The medication effect was inconclusive due to violations of IV criteria. For individuals who used illicit drugs, the effect of medication was indeterminate. We also performed traditional logistic regression to compare the result from the instrumental variable estimation. Both counseling and medication showed a positive correlation with suicidal ideation, suggesting that treatment increases the possibility of thinking of suicide. The result was significant with a p-value under 0.001. We assume that this result might be affected by unobserved confounders. For Figure 3, this figure shows the bounds of average causal effect, ACE, of counseling and medication on suicidal ideation, illustrating the range of estimated effects under different conditions. Our study highlights the challenges in establishing causal relationships in depression treatment. While IV estimation did not provide a definitive answer, it suggests that previous studies may have spurious effects due to confounding factors. The instrumental inequality check adds value by partially validating our IVs and enhancing precision. No clear causal link was found between counseling or medication and suicidal ideation, differing from strong effects seen in logistic linear models. This suggests past research may not have controlled for confounding variables and effects adequately. This study highlights the potential influence of a third variable on significant effects seen in previous research. Although our study does not definitively establish a causal relationship between depression treatments and suicidal ideation, it provides insights into the complexities of such analyses. Further research with refined methodologies is needed for clearer conclusions. I thank my mentor Jiwoo Kim for her invaluable guidance and the SRI Harvard program for this research opportunity, which has significantly advanced my research experience. Thank you for your attention.
Thank you very much, Bhavya. Wonderful job. Okay. You should have all seen in the chat, just as a reminder, after you do your presentation, you're welcome to switch to other rooms. There are lots and lots of interesting things, though room 2 is the best objectively. Just to keep in mind, if you have other friends in other rooms or anything like that. Okay. Next, we are going to stay on track. We'll be hearing from Brendan Wu, mentored by Divyanshu Kumar. The project title, Comparative Review of 2D Material-Based Contrast Agent versus Gadolinium-Based Agents for MRI. Brendan, we will get started at 11:12. So we'll just take a minute, everyone. So feel free to, get a drink of water, step away from the computer for 1 minute or two, or check out other presentations. Love to see Azzy's room 2 pride. That's what we want. Okay. All right, Brendan, as it's now 10:11, feel free to start whenever you're ready. We'll go until 10:17.
An estimate of 2.4% patients dosed with gadolinium-based contrast agents prior to performing an MRI scan experience adverse effects. This was a driving statistic that drew me towards my research, launching a comparative review of 2D material-based contrast agents versus gadolinium-based contrast agents, which involved compiling over 20 different articles. But first, in order to understand my research, let's start with a brief overview of MRI. Magnetic resonance imaging, better known as MRI, uses strong magnetic fields and radio frequency radiation to create detailed images of body tissues, and it does this by measuring the relaxation times of hydrogen nuclei, which is basically water. Contrast agents are substances injected into the body to enhance MRI images. They work by shortening the relaxation times of water protons, which improves tissue visibility and helps detect abnormalities. Gadolinium-based contrast agents is currently the gold standard for MRI scans, and I've included a graphic on the bottom that demonstrates without GBCAs and with GBCAs, we see that it's better visualizing the MRI, and we can see a tumor, which helps in diagnostics. Now let's go over to the world of 2D materials. These are crystalline solids with a single or few layers of atoms. They're notable for multiple different properties, including high mechanical strength, electrical conductivity, thermal conductivity, optical transparency, amongst many others. And 2D materials have a high surface area and are able to chemically functionalize with biomolecules, which allows them to have specific applications in biosensing and MRI scans. So throughout my research and during my literature review, I took multiple different criteria like stability, cost, imaging performance, and others to compare which one is better, but more specifically, differentiate the nuances and the potential of 2D material-based contrast agents. In terms of stability, when we're comparing them, we see that GBCAs are generally stable in vivo, but can degrade over time or under certain conditions. In contrast, 2D material-based contrast agents are known for their high chemical stability, and through further evaluation, we're able to determine if they're able to degrade within the body as well, which they have been able to within specific contrast agents based on MX scenes, one type of 2D materials. In terms of cost, we see that GBCAs have a complex and expensive synthesis process, leading to higher production costs and significant clinical costs, especially with the risk of their adverse effects. On the other hand, 2D material-based contrast agents may offer cost advantages despite production still being limited. However, over the past 20 years, we've seen through using methods such as exfoliation, this production cost has been able to become reduced. Now, the big metric, imaging performance, in terms of imaging performance, GBCAs are known for their high image resolution and clarity, but require more precise dosing, and 2D material-based contrast agents, on the other hand, offer more competitive or superior contrast quality in some specific studies. However, we do see that GBCAs ultimately have more widespread use, and 2D material contrast agents are still under development. On the hand of safety, we see the biggest issue, and leading back to that statistic I mentioned earlier, are that GBCAs can induce two main symptoms: nephrogenic systemic fibrosis or gadolinium deposition in the brain or the body, which is what makes GBCAs so risky. On the other hand, 2D material-based contrast agents have been showing promising preliminary results with potentially lower toxicity, better biocompatibility, and less likelihood of causing the same renal issues that GBCAs have. Ultimately, from my research, we can conclude that both GBCAs and 2D material-based contrast agents have their own sets of advantages and challenges. And while GBCAs have remained the standard and may continue to do so for decades to come, we have to look towards the future and not accept compliance with the current safety risks that they hold, and look towards the future once again and the potential of 2D materials showing great potential in cost, safety, and imaging performance. While further research and development are warranted, it's a great look towards the future. Before the ending of my presentation, I just want to acknowledge a couple of people: Kumar, my mentor, all of you guys for being here, Sahil and Sean for launching SRI, and all of the guest lectures that we've had over time. Thank you so much.
Well done, Brendan. Thank you very much. Next, we'll be hearing from Brian Zhu, mentored by Charelle Connor. The project title Sugar Pal, Personalized Blood Glucose Management for Insulin-Dependent Diabetes Patients Using Deep Learning. Brian, we'll just take another minute or so, and then you will have until 1:23 for your presentation. Brian, feel free to start whenever you'd like.
Right. Hi, everyone. So happy to be here today. I'm Brian, and this is my project Sugar Pal. So brief background, diabetes is a chronic condition that you always have to worry about. It's not a one and done thing. You always have to manage it properly. And if you don't manage it properly, there can be long-term complications such as organ damage, which coincidentally includes eye damage, which Augustus presented about earlier. These complications collectively lead to 6.7 million adult deaths every year. Now, despite technologies like the contemporary closed-loop system, there are still multiple challenges currently, the biggest one being the lack of future forecasting ability and blood glucose, or BG, alerts happening too late. Consequently, most diabetics cannot reach their therapeutic goals. And I'm going to acknowledge to some extent that includes me as well. I have type 1 diabetes, and sometime last year, my blood sugar was really high, and I added a ton of insulin, and then it went really low for an entire night, and I lost a couple weeks of memory as a result of that. So yeah, not my proudest moment. And that's where Sugar Pal comes in. TLDR, Sugar Pal predicts future BG values to help diabetics improve their health. It consists of three main components: the AI model itself, which I call SugarNet. SugarNet is basically what makes the actual BG forecasts, plus the app, which is for the base model. And there's also the cloud web service for progressively fine-tuning the base model. Now, for data and features section in the bottom left, much of the existing research uses one feature for insulin, but I use three to highlight the different medical purposes of different types of insulin. I also use a basal learning algorithm that I believe has yet to be seen in BG forecasting research, plus food, medications for type 2 diabetes, and BG values. So moving on to the ML model itself, generation 1, which is the old version, consists of 3 convolutional layers and then 1 LSTM layer and then 3 dense layers. Generation 2 is kind of like the more updated, more up-to-date version. It's basically a slightly improved version of generation 1. To the best of my knowledge, this is the first ever model to use a frequency domain and an embedding block in BG forecasting research. So those are the two things that make generation 2 really distinct from generation 1. And Sugar Pal also relies on a transfer learning model, which means that the base model is first trained on other patients, because when a new person first gets the app doesn't have any of their data, and so it doesn't really know them. And so it makes predictions using what it's learned from other patients. But as the user gets more of their data into the app gets to learn them better. And so this fine-tuning is what improves the app's forecasts of their BG over time. So for experimental results, the dataset contains over 150 patients with around 20 years of data. Using 3 error metrics, root mean square error, mean absolute error, and mean absolute percentage error, it can be seen that the transfer learning model is better than the other models and outperforms 8 state-of-the-art models in the existing literature, including transformers and graph neural networks, as seen on those charts in the bottom of the middle column and on the graphs in the top of the right column. Especially on those 2 graphs in the top right, it can be seen that the dashed blue line is the actual BG values, and it can be seen that Sugar Pal is significantly closer to the dashed blue line than all of the other models. And it also has much lower error rates, as seen in those two graphs at the far right top side of the poster. And another metric I used for evaluating Sugar Pal was the Clark error grid analysis, which indicates the clinical significance of results. Basically, the big idea is that the closer to the dashed line it is, the better. And it can be seen that SugarNet, which is the AI model component of SugarPal, significantly outperforms all of the existing literature. So for the ablation study, an ablation study basically means disabling different components of a project to see their overall contributions to the overall results. And it can be seen that the frequency domain, the time domain, and the embedding technique all positively contribute to the overall results. So in conclusion, by forecasting future BG values in advance, the SugarPal app helps diabetics manage their health better because they can make decisions with greater advanced knowledge of what's going to happen. So thank you so much to my mentor, Charelle Connor, and thank you so much for the entire SRI staff for organizing this program. And thank you all for listening. I hope you learned something new.
Thank you very much, Brian. Well done. Okay. Next, we'll be hearing from Catherine Lee, mentored by Valeria Saro Cortez, with the project titled A Patient-Centered Comparison of 3 Popular Pseudoachondroplasia Treatments. The presentation will go from 10:24 until 10:29. Catherine, feel free to begin whenever you're ready.
So hi everyone, my name is Catherine Lee and my project is focused on the popular treatments of pseudoachondroplasia used in the patient community. And a brief background on pseudoachondroplasia, or for short PSAC, is that it is a form of dwarfism caused by a mutation in the COMP known as the cartilage oligomeric matrix protein found in articular cartilage. It serves as a cushioning to prevent friction in the knees. Due to the mutation in the COMP, symptoms of PSAC include short stature and laxity of ligaments in the knees, hips, and ankles, bowed legs, knock knees, and early onset osteoarthritis, which is a degenerative joint disease that occurs when the cushioning function of the cartilage wears down over time. This condition is extremely rare, with 1 diagnosis in every 30,000 people. And for my research, I decided to compare cost, pain alleviation, and limb growth for these treatment options: resveratrol, Taylor spatial frames, abbreviated as TSF, and Alizarov external fixators, also abbreviated as IEF, and which are categorized as orthopedic surgeries. I chose these 3 options because they are most frequently used treatments in the patient community, and I was motivated by my little brother who was diagnosed with this condition when he was 2 years old. The fixators, which are external surgical devices that correct bone deformities, are expensive to install due to advanced surgical techniques and training. Since PSAC is a rare skeletal dysplasia, surgeons who specialize in this type of surgery are less likely to be found due to the complicated process. However, patients who can afford orthopedic surgeries also face numerous challenges. The existing pain in the joints, complications, and risk of wearing fixator, and the continuous need for surgeries. But the results are rewarding because a clinical analysis has shown that the success in the target aim correction for the TSF and IEF is high. The Taylor spatial frames are higher than the IEF, Alizarov external fixator, because they allow room for frequent adjustments on the computer program and fix the deformity in a multiplanar perspective. Thus, it is considered as the upgraded version for IEF. But although IEF does provide stability for the frames, frequent adjustment cannot be easily made. So surgeons will have to be especially meticulous in calculations during planning and surgery. And if you can see on the right-hand corner where it shows figure 1, that's actually a picture of my brother. He had this surgery. He had Taylor spatial frames attached to his legs last May, and he's 8 years old. And and it basically shows a lateral view of what the fixators will look like on a patient who have knock knees or who have bowed legs. Sorry. And then for the second figure, you can see it's a picture of a patient with a litter of external fixators, knock knees. And this patient, although I don't know the exact age, but I can assume that it's a child. And from there, moving on to resveratrol, which is a type of antioxidant found in fruits such as grapes and blueberries, is also considered expensive due to the complexity of the extraction process and inaccessibility for middle class people in numerous less developed countries. But despite the pricing, resveratrol is popular in the patient community for its function as a short-term pain reliever, and it does so by temporarily inhibiting the mutation in the COMP. The reason behind its inability to stay long-term is due to the poor bioavailability after consumption. So it will have side effects such as diarrhea and nausea. However, preclinical studies have shown that the intake of resveratrol in PSAC mouse models of 4 weeks preserves joint health, and treatment between 6 to 8 weeks does not prevent joint degeneration. From the success in preclinical studies, a clinical trial was conducted on 6 adult participants, where their pain levels were assessed on a scale of 0 to 10 after taking resveratrol. However, the result of the trial was not revealed because it was discontinued due to the shortage of people. And the lack of pediatric patients in the trial also limited the scope of insight into the condition, since majority of the patient populations are children and adolescents. Taking both TSF and IEF along with resveratrol into consideration, pain level management is the best in TSF compared to IEF, and along with resveratrol, because IEF cannot make fine-tuned or gradual adjustments and is complex skill set. For resveratrol, it can only provide short-term pain relief because it is metabolized quickly. Then the cost of resveratrol is more affordable than the surgical fixators because the raw materials and processes are less expensive than surgical procedures. However, TSF accounts for more growth for limb lengthening because IEF does not have constant perfect precision and it lacks technological advancement to adjust the frames, while resveratrol can only provide temporary pain relief. Thus, TSF is a better predicted treatment option for PSAC patients. And through my analysis of these treatment options, I believe it will open more windows of opportunity for future research to be conducted on these treatment options to find an eventual cure and promote awareness of this condition to the general public. And also shout out to my mentor. She helped me tremendously on this project. I cannot thank her enough. And thank you for the staff for the Harvard Open Bio Laboratory. I'm so thankful for this opportunity, and thank you guys for listening.
Thank you very much, Catherine. Great job. Okay. Now we will be hearing from Christina Tay, mentored by Echo Shoot. The project Computational Modeling of Uterine and Endometrial Mechanics Across Menstrual Phases Using Non-Human Primate Data. Presentation will go until 10:35. Christina, feel free to begin whenever you're ready.
Okay. Hi, my name is Christina, and this is my project. So, despite 1.8 billion people menstruating monthly, there is a lack of research on the mechanics of the uterus and its layers during the menstrual cycle. During the menstrual cycle, progesterone and estrogen hormones alter the endometrium, the innermost layer of the uterus, to prepare it for embryo implantation. Studies in the rhesus monkeys and humans show a correlation between endometrial thickness during high concentrations of serum estradiol, a primary form of estrogen produced by the ovaries, and the success of assisted reproductive techniques. To improve reproductive technologies, computational models of the menstrual cycle could be helpful. So today I'll be presenting 2 models representing different phases of the uterine cycle. Obtaining uterine dimensions from non-pregnant humans is challenging and requires invasive procedures because of the protective nature of the uterus. So we use data from bonnet monkeys, focusing on their uterus and endometrium dimensions during the late proliferative and mid-secretory phases of the menstrual cycle. The endometrium thickens during the late proliferative phase as serum estradiol levels peak and progesterone levels rise in the mid-secretory phase to preserve the tissue. Due to limited data, we simplified the model by combining the outer uterus layers, which are the myometrium and the perimetrium, into one layer and concentrated on the endometrium changes. As you can see in the top of the middle column, like past models of the uterus of pregnant women, the CAD models assume symmetry and use an elliptical shape. The lighter blue regions represent the combined myometrium and perimetrium layer, and you can see the dark blue represents the endometrium, and the whole is the uterine cavity. So in the middle, you can see a side-by-side comparison that shows the mid-secretory model on the right side has a thicker endometrium, which is expected since it represents a later phase in the cycle. So next, we used finite element analysis to simulate the mechanical behavior. Finite element analysis divides a structure into small elements connected at nodes, forming a mesh. Our models were imported into the software FEBio and meshed with 4-node linear tetrahedral elements. We applied the neo-Hookean material to both layers using a lower Young's modulus to make the endometrium softer and more deformable, and the Poisson's ratio indicated that both layers were nearly incompressible like biological soft tissues. We applied boundary conditions to fixed nodes and prevent sliding between layers, and we also included a load simulating an intrauterine pressure of 1 kilopascal. As pressure was applied to our simulation, the uterine cavity expands. As you can see, the mid-secretory phase model is the one at the top with the colors. It shows that expansion a little bit. So we generated 3 graphs for each model: first principle Lagrange strain versus time, first principle stress versus time, and displacement magnitude versus time. The top graphs show the late proliferative phase model, while the bottom graphs show the mid-secretory phase. I have a more detailed explanation on the top right of the material behavior, but the key points are that the first principle stress is the most tensile and most positive or negative of the principal stresses. The first principle Lagrange strain indicates the maximum normal strain at a point, and the displacement magnitude measures the shortest distance between an object's initial and final positions. So the color maps reveal that the stress concentration is the highest at the end of the endometrium in both models. The mid-secretory phase shows significantly greater tensile strength and strain compared to the proliferative phase. This aligns with the physiological changes during this phase when the endometrium remodels and undergoes cell differentiation to support potential embryo implantation. The endometrium also shows more displacement in the mid-secretory phase compared to the proliferative phase. This is expected as the body ensures the endometrium is optimal for pregnancy, adjusting its thickness throughout the cycle during the mid-secretory phase. Understanding the stress and strain behavior of the endometrium is crucial for comprehending how the uterine lining supports embryo implantation. Additionally, the displacement magnitude data could aid in predicting optimal implantation sites for assisted reproductive technologies. Future work should refine these models with more accurate geometries and complex material properties to better simulate the different uterine tissue behaviors. This project was kind of a passion project for me, and I would like to thank my mentor, Echo Zhu, for her invaluable help during this program. And thank you all for listening.
Very well done, Christina. Thank you so much. All right. Our final presentation of the day will be from Cyrus Guy, mentored by Anna Mania, presenting the work of the hierarchical spatiotemporal dynamics of the visual system in mechanics. Cyrus, feel free to take it away when you're ready, and you have until 10:41.
Thank you. So hi, I'm Cyrus, and today I'll be talking a little bit about the hierarchical spatiotemporal dynamics of the visual system in the macaque monkey. So before I begin, let's talk a little bit about the visual system. So we define a visual area as a region of the cortex that's distinct from its neighbors in function, specific connectivity, and or structure or cell type. So the brain processes visual information as visual input from the retina, and that's transferred through a series of pathways to visual area 1, also known as the primary visual cortex or V1. After this information leaves V1, it becomes quite complicated. So although it can be roughly divided into a dorsal pathway that is It deals with visually guided action like catching a baseball, and the ventral pathway, which deals with recognizing objects, words, and faces. So today I'll be primarily talking about visual areas 1 to 4 and the various subparcellations of it. So now let's transition to the temporal part of spatiotemporal, that is the concept of intrinsic neural timescales. So to illustrate this, I'll be giving an example of, let's say you trip and skin your knee. How do you react? Well, the short answer is your brain operates across multiple timescales. So this answer might not make sense initially, so allow me to clarify. In the milliseconds and seconds after you fall, you have to integrate sensory input and motor control at any time. However, this is all embedded into a broader temporal context, that is the minutes after you fall, where you're assessing the injury and determining preliminary treatment. Finally, this is in turn embedded into an even slower timescale, that is the hours after you fall, where you're dealing with long-term recovery. So we see that an action is the result of integrating and processing information over multiple timescales as they're trying to achieve the goals that are embedded into these timescales. So how does the brain do this? Well, in 2014, Murray and colleagues showed that neurons have different timescales at rest, revealing a hierarchy extending from sensory to association areas. Now let's talk a little bit about the spatial part of spatiotemporal. So this deals with the gradients of functional connectivity, or FC. So these gradients are derived from fMRI data and have emerged in recent decades as a powerful tool to elucidate the brain's large-scale functional architecture. So the problem we investigated in this study is that the macroscale functional architecture of the brain is poorly understood. And we look to ask, what is the relationship between temporal and spatial dynamics in the visual areas? And we claim that INTs, or intrinsic neural timescales, are distributed along spatial gradients that closely match that of FC gradients. So let's transition to how we did this study. So we started with inducing anesthesia into 5 macaque monkeys, and then we acquired fMRI data using a 10.5 Tesla magnet. We pre-processed data, and finally, we applied Pearson's R correlation to determine the FC-INT link in MATLAB. So transitioning over to some results, we overall determined that there is a significant correlation between functional connectivity and intrinsic neural timescales. You can see the tables in the results section. You might note that in the subject level correlation values in V1, V2, and V2/V3, the correlation values are all quite low. And this is expected because the data tends to get quite noisy in those areas since you have just so many voxels. So that's why we need to average them to the group level to get meaningful correlations. So we also saw that these gradients reflect organizational principles of these visual areas. For example, if you look at part A of the diagram, V1, there's an anterior and posterior axis in V1, which reflects the distinction between foveal and peripheral processing. And we see similar axes of organizations in V2 and V3, or B and C in that diagram. We see ventrodorsal and medial to lateral axes. And similarly in V4, and this all reflects previously documented findings in literature. So our results are agreeing with that. And interestingly, we saw INTs and FCs became slower as one moves from the lateral to medial portions in V2. And we hypothesized that this might be to facilitate the integration of fine-grained visual information. And also in V3, we also found the well-known ventral to dorsal axis, and we reinforced like the difference between the what and the where/how pathways in V3 and the dorsal and ventral parcellations. So just to recap on what I talked about today, I showed that intrinsic neural timescales are topographically organized along FC gradients throughout the cortical visual system in macaques. We also showed that these correlations reflect the functional organization of these visual processing pathways and corresponded our findings with previous literature. Also, we found a significant voxel-wise correlation, and we hope that highlights the utility of high-resolution neuroimaging of elucidating brain function. So as for future work, we hope in the future that our examination of functional connectivity can provide insight into how disorders like visual snow syndrome might arise from disruptions in functional organization. And we would hope to investigate how individual variation in the correspondence of connectivity gradients could relate to aspects of cognitive function. And finally, although this isn't possible yet due to technological constraints with RS fMRI imaging, we would want to identify dynamic information flow in brain regions with low signal-to-noise ratios. I would like to thank Anna Manea for her invaluable mentorship and the Zimmerman Lab for graciously supporting our data. And finally, the Harvard Undergraduate Open Bio Laboratory for providing the platform resources to conduct this project. Thank you for listening.
Well done, Cyrus. Thank you so much. Well, unfortunately, that brings us to the end of our presentations for today. You all did incredibly well, and I learned so much. This was from areas completely different than what my science is, which is immunology, so I really, really enjoyed it. I hope you all feel really proud of your work. You're posters look fantastic. You were clear spoken. You conveyed your information well. Yeah, I had a wonderful time, and I hope you did too. Thank you, Brian. I appreciate it. So we are going to pop back to the main room now. For everyone else, there's going to be, a few minutes of closing. We're just waiting on a couple of people to finish too. And then, yeah, we'll have closing. I hope SRI has been a really, really positive experience for you all. I know summers are busy in high school, and it means a lot to us that you've had the opportunity to work this summer with us and with your mentors and do research. Hopefully going forward, you feel that this has been an impactful experience and that you continue to, think positively on it. I'm always accessible if you have any questions about Open Bio or, being an undergrad, doing research, and you can reach out to my email. Just let me know that you were a part of SRI, and let me know you're in room 2, best room. Okay, so feel free to head back to the main chat, and I'll see you in a sec. All right.
Thank you.